Welcome to the live session. So the topic we are discussing about acids and bases, and also about salts. In last discussion, we started discussing about especially what are salts, how they prepared, and importance of common salt in our day-to-day life. The topic we started, and also we discussed about importance of common salt in our daily life. With that, what are the other salts we are producing, right? So preparation of a bleaching powder discussion already completed in yesterday's live class. I'll repeat that once again, just to discuss about further information related to other salts in our day-to-day life. So here, preparation of bleaching powder. Simply, that bleaching powder is produced by the action of chlorine on tricyclic line. So here, simply calcium hydroxide we will produce, and somewhat it is wet. Calcium oxide plus water will give you slacked line. So when you dry it, you will call this as a dry slacked line. Dry slacked line. So here we are supplying chlorine gas onto the dry slacked line. So here bleaching powder is produced by the action of chlorine gas on dry slacked line. Then here you will get a compound called bleaching powder. Its name chemically calcium oxychloride, or sometimes you may call it as calcioxychloride. Chemical name of bleaching powder is calcium oxychloride or calcium chlorohypochlorite. This is called as bleaching powder. Uses of this bleaching powder in our daily life. So what are the applications of this bleaching powder in our day-to-day life? They are here. This bleaching powder is used as oxidizing agent. Used as oxidizing agent. So here oxidizing agent means that which can supply oxygen for the other compound, and itself it will be reduced. So that substance is called as oxidizing agent. So here this bleaching powder is used as oxidizing agent in many chemical reactions. Also, this bleaching powder is used as a decolorizing agent to remove the color of other substances. So here in paper industry, to treat the wood pulp, bleaching wood pulp, right, to change the color of that pulp, that we can use. Bleaching powder also used in a cotton and a linen textile industry for bleaching purpose to remove the color. This also used as a purification process purpose. That means supplying of a chlorine, disinfecting cleaner, or sterilization of water. So that bleaching powder helps to disinfect the water. As a source of chlorine, we are using this bleaching powder. It is also used in the manufacturing of fertilizers, insecticides or weedicides in fertilizers. Used as a reagent in a preparation of a chloroform as source of chlorine, CHCl3. Right? Sorry, CH3Cl. Right? So that purpose we are using bleaching powder as a source in the preparation of a chloroform. Then the next salt we are discussing in this important salts is baking soda. In baking soda. So here directly or indirectly, we are depending on NaCl. Maybe you are producing by using NaOH, or maybe you are producing the other salts using byproducts like hydrogen or chlorine, whatever it may be. So here simply you are using NaCl or NaOH. So here preparation of baking soda. How we can prepare that baking soda? So here baking soda is prepared by saturating of NaCl solution with ammonia and carbon dioxide. Right? Here baking soda is prepared by saturating NaCl solution with ammonia and carbon dioxide is passing. So here NaCl solution you are preparing and you are supplying the gases. Right? So here NaCl plus H2O gives as NaCl solution, aqueous solution, then passing ammonia and carbon dioxide into that liquid solution of NaCl. Then finally you will get a liquid solution, right? And the precipitate. They are here ammonium chloride and sodium bicarbonate. So this sodium bicarbonate called as baking soda. Sodium bicarbonate is called as baking soda. Okay. So here simply baking soda produced by using the NaCl solution and ammonia, carbon dioxide gases, two gases. This is. Then here, what are the applications of this sodium bicarbonate? Applications of sodium bicarbonate. So here, this sodium bicarbonate is used as antacid, mild, basic in nature. Sodium bicarbonate is mild, basic in nature to remove acidity in our stomach. We are using as mild, basic substance as antacid here. It is a common antacid to remove acidity of our stomach. So we can consume it to prevent burning sensation or stomach pain, right? So here used as antacid. Here antacid means basic in nature. The substance which is basic in nature, that is called antacid. So here used as a common antacid to remove the acidity of a stomach. It is used in the preparation of a baking powder. What is baking powder here? It is a substance which is treated, this baking soda, by tartaric acid. Baking soda and tartaric acid, or sometimes citric acid, right? So that is called as here baking powder. It is used in the preparation of baking powder by adding citric acid in it. So in a cooking process, we can use baking powder to cook different food items. It is also used in the preparation of soda water. It is also used as a soda water in cool drinks because it can supply carbonic acid. Also, this baking soda used as fire extinguisher because of source of carbon dioxide gas on decomposition. It is used as fire extinguisher for instant production of carbon dioxide. So it can supply the carbon dioxide. That carbon dioxide extinguishes the fire. Baking soda also used as mild antiseptic on the skin. So here it can control that. Mild antiseptic as lotion or in preparation of that ointments to control skin defects, infections. Baking soda used as antacid. Baking soda is used in the preparation of baking powder. Baking soda used in preparation of soda water. Baking soda is used as fire extinguisher. Baking soda is used as mild antiseptic lotion or ointment for controlling the skin infections. The next salt is here to discuss that the topic is preparation of a washing soda. Preparation of a washing soda. How we are preparing that washing soda. So here, simply washing soda formula is sodium carbonate. That sodium carbonate is prepared by using the baking soda. By using the baking soda. So here, that baking soda is heated and recrystallized. So to produce sodium carbonate, here recrystallization, adding water, solidify. Okay, so here what we can do in this process? Nothing. Here we have sodium bicarbonate, that is called baking soda here. So that gets heated, decomposition reaction takes place. So in this process, it can lose water molecules and carbon dioxide gas from it. Then it can produce sodium carbonate salt. So this can be added by 10 water molecules. Then produced ice Na2CO3 10H2O. This is known as washing soda. Washing soda composition formula or compound formula. So that composition is Na2CO3 10H2O. Don't write Na2CO3. Na2CO3 10H2O. This 10H2O is called as water of crystallization. 10H2O, number of water molecules, water of crystallization. Then next one is here applications of this washing soda. What are the applications in our day-to-day life? So here this washing soda is used in the manufacturing of detergents, soaps. In the manufacturing of detergents, we can use washing soda. It is used to remove the permanent hardness of the water. This washing soda is used for removing the permanent hardness of water. Used in the preparation of detergents and use it to remove the permanent hardness of the water. Also used in cleaning or in the manufacturing of glass and soap and paper industry. For washing, used in a manufacturing of glass, soap and paper industry. It is also one of the important components for manufacturing of borax powder, caustic soda. Borax powder and caustic soda. We can use this with suitable compounds to produce borax powder and caustic soda. Also, it is used as cleansing agent for domestic purposes in the houses. In the domestic purpose, we are using as cleansing agent. So simple applications are there. What they are here, that applications are, it is used in the manufacturing of detergents to remove the permanent hardness of water, manufacturing of glass, soap and paper industry. Used as important source or important compound in manufacturing of borax and caustic soda. Also used in domesticated purpose, cleansing agent, as cleansing agent. So these are the applications of washing soda. Applications of washing soda. Then the next salt is here It is about a plaster of Paris. The discussion is about a plaster of Paris. So here, how we can use this plaster of Paris in our day-to-day life, and how to prepare this salt, plaster of Paris. So here simply it is produced from the gypsum salt. It is produced from the gypsum salt at a particular temperature, 100 degrees Celsius or 373 degree Kelvin. It is 100 degrees Celsius or 373 degree Kelvin. Just remember the relation between here temperatures, that is in degree Celsius on degree Kelvin scales. So in both scales. So here the relation is simple. 0 degrees Celsius is equal to 273 degree Kelvin. So here you need 373 degree Kelvin. So what the difference is here? 100. So that 100 will be added on both sides. Simple relation is there. Will be added on both sides here. So 373 degree Kelvin, and here also you can add simply 100. So what you'll get here, sorry, unable to write, just a second. degree Celsius. So by adding simply 100 to this one, I'm getting this relation on both sides. So this is the relation simply. So here 100 degrees Celsius is equal to, on the Kelvin scale, showing you 373 degree Kelvin. 100 degrees Celsius is equal to 373 degree Kelvin. So this is the relation. This is the relation we have. Then here simply we'll go for the equation. So what is that? So gypsum formula is CaSO4 2H2O. CaSO4 2H2O. By removing 1.5 molecule of water, 1.5 water molecule from the gypsum salt. So what is gypsum salt here? CaSO4 2H2O. CaSO4 2H2O is called gypsum salt. So here from this you are simply removing 1.5 water molecule at a particular temperature called 373 degree Kelvin temperature. So on heating, CaSO4 2H2O compound loses 1.5 water molecule and remains with, here there is a mistake in this, half water molecule. CaSO4 half H2O. CaSO4 half H2O. That remains. Then it loses its 1.5 water molecule. 1.5 water molecule. So here simply CaSO4 2H2O heated at 373 degree Kelvin temperature. Then it is losing 1.5 water molecule and remains with only half water molecule. Half water molecule. So CaSO4 half H2O. CaSO4 half H2O is a composition formula of a plaster of Paris. So like this you are preparing plaster of Paris. So what its formula is here? Its formula is CaSO4 half H2O. CaSO4 half H2O is the formula of plaster of Paris. So here we know the preparation method. On heating of gypsum salt, you are preparing plaster of Paris. It is simply formula of plaster of Paris is CaSO4 half H2O. Then how we can use this plaster of Paris in our day-to-day life in different sectors. So here, plaster of Paris, suppose if anyone injured, their bones may be cracked or fractured, broken, break. So that can be setting. That can be setting and used as a support for that fractured bones as a plaster. So that substance is plaster of Paris. So that substance which doctors use as a plaster for supporting the fractured bones. That plaster is called plaster of Paris. Plaster of Paris. So here actually this plaster of Paris, soft material, right? It can be preserved. Then once it is exposed to the air, what happens? It becomes very hard. It becomes very hard substance. So that's why it is used as supporting substance for the fractured bones as a plaster here. Then it is used in making of a chalk pieces to produce calcium carbonate. So used as making of a chalk. Also used it is as in the packing, as airtight packing. It is used in the airtight packing. So in a packing sector they can use it. Here it can be used in making of toys because it is very soft material actually, smooth and also becomes very hard, right, on exposing to the air. So here used in the making of toys, also in making of statues. For example, in making of Vinayaka idols. Vinayaka, Lord Vinayaka, that idols are made using a plaster of Paris. It is used in the designing of materials for fireproof or fireproof fabrics, used in the making or designing of materials that which are fireproof, like fabrics. Also used in a decoration purpose in houses, that walls are smoothed, ceiling designed, roof ceilings designed. So here as a decorating, we can use this plaster of Paris. Here used in a cement. For what? Delaying the setting time. It is used in the cement to delay its setting time. So it maybe takes more time to become hard. Right? So here plaster of Paris on mixing with water sets into hard solid, converted into gypsum again. Here what happens on adding of water here? Suppose that a plaster of Paris we are using CaSO4, half water molecule, half H2O. If added by water molecules, how many? 1.5 water molecules. What happens? That again changes its nature into gypsum salt, CaSO4, 2H2O. It changes into CaSO4, 2H2O. So this is actually happening here. Right? So on mixing of water to the plaster of Paris, what happens? Changes into gypsum. When you remove 1.5 water molecule from the gypsum, you are able to produce plaster of Paris. If that water of molecules added reversely, then what happens? Gypsum. It's a reversible process. So this we'll learn in this topic here, right? So these are the topics. Then the next one is simply production. So here CaSO4 half H2O with 1.5 water molecule again convert into gypsum. Then the next topic is about here activity number 16, last topic of the lesson. Activity 16. It is specially about water of crystallization. Our target is to observe water of crystallization. So here, what is water of crystallization here? What is water of crystallization? Here, simply crystal means solid. Crystal means solid. So here, in that, there is a spelling mistake. CRY actually. So here, what is crystal? Crystal means solid form. So in the solid, do you have any water droplets? Is it dried salt or wet salt? Is it dry salts or wet salts? If it contains moisture in it, maybe it is looking like a dried, but if it present with water, then that solid is called as water of crystallization, right? It contains that water in the solid in solid form only. Water droplets present in the crystal in solid form. So that is called as water of crystallization. Our aim is to observe the water of a crystallization. Here, you are required some materials to conduct this activity. Here, what are the required materials? So here, simply you are observing the presence of water droplets in a solid salt. So you required hydrated copper sulfate. We can call it as hydrated copper sulfate. Its formula is hydrated copper sulfate. Its formula is CuSO4 5H2O is called as hydrated copper sulfate. This 5H2O is called as number of water molecules present in the dried salt. So that is called as water of crystallization. So we will observe that clearly in the activity. So here hydrated copper sulfate is needed, and you are required a boiling tube or a test tube. So here you have to heat this hydrated copper sulfate taking in a test tube. For heating purpose, you are required a candle or a laboratory source is called Bunsen burner. So here simply we have what they are here: Bunsen burner, hydrated copper sulfate, test tube. So here we need to hold the test tube or boiling tube. So here pair of tongs, or we can use laboratory stand, anything which is available. Then here you require water to observe change in the color by adding water. Then you need a watch glass to collect these samples, or directly you can use that same boiling tube or the test tube. Then simply these are the required materials. Then what is the process here? How to conduct this lab activity? Hold that boiling tube or the test tube. Using pair of tongs. After the procedure completion, you can note down your observations. So here I am holding that boiling tube using pair of tongs. Okay, I hold it. Then adding the salt. What? Hydrated copper sulfate. Remember that the color of hydrated copper sulfate is blue. That salt is available in a blue color. Hydrated copper sulfate available blue in color. So hydrated copper sulfate is taken into the Bunsen burner. Then what to do? Just we have to heat it using Bunsen burner. So heating that, observe that boiling tube carefully. What happens into the boiling tube while you are heating? Slowly, what happens? That color of the salt changes and sometimes that some droplets on the inner walls of the boiling tube, you can observe water droplets slowly forms on heating the hydrated copper sulfate. So simply what we can generalize here, on heating hydrated copper sulfate losing its color, that blue color vanishes, loses its blue color, changed into white crystals. And you observed here water droplets formed on the inner walls of a boiling tube. So how these water droplets forms? Because you are doubtful. Why? Because here simply you are taken a dried salt. Nothing is added other than salt. So here the droplets may be because of the salt, right? It may be loses in the form of vapor that can be condensed on the surface of this. Then that sample salt you can take into a watch glass. So that heated copper sulfate, hydrated copper sulfate, after heating, right, that is taken into a watch glass. Here on heating, what we notice, blue color copper sulfate, hydrated copper sulfate changed into white crystal. That sample we are taken into the watch glass. Then what to do? Add 2 or 3 droplets of water on the sample. So you can keep one sample in one watch glass, some sample into another watch glass, then add one of the sample by water droplets here. Suppose here on the second watch glass, I am adding few droplets of water. Then what happens on adding water droplets on the heated copper sulfate, white crystals of copper sulfate? What happened? It reappeared in blue color. It reappeared in blue color. So simply what we can observe here, what are the observations you made on heating? On heating, that water droplets inside on the side walls of test tube formed. Droplets of water are formed. Then I added few droplets of water on the heated copper sulfate. So after adding 2-3 droplets of water on the sample of copper sulfate heated, obtained on heating, that reappeared in blue color. So here simply reappearing of blue color due to what? Addition of water. So we added water droplets. Due to adding of that water droplets only, it may be reappeared blue color. So for the blue color of copper sulfate salt is maybe presence of water droplets. So in the solid, water is present. Due to that water, we observe that color of copper sulfate is blue. If water droplets are removed, we observe that in white color. So simply we can define what water of crystallization is. The number of water molecules present in the salt is called water of crystallization. What is water of crystallization here? Simply the number of water droplets present in the solid salt is called as water of crystallization. So simply our result is the blue color of copper sulfate is restored by adding of water droplets. So this is simply about the activity number 16 and totally about the acids, base and salts. Total number of activities are here 16. That total activities discussed through these online classes. Number of classes 7 taken. So here observe all the classes what you learned. Watch that videos again. If there is any confusion, put your comment. I'll try to explain them in other classes or maybe through the text information. So please give me your valuable comments. Do you like or not? Don't forget to share this information with your friends. Thank you. We'll discuss about the new chapter in other live classes.